In this video, we are going over horizontal and vertical translations. So I'm going to first start off by walking you through the animation, and then we'll come back to the handout.
There's C and D. So what I have here, f of x, is our parent function, which I made it to be the quadratic function. I'm going to change it in a second because it doesn't really matter what the parent function is. The effect of C is going to be the exact same. And g of x is equal to f of x plus c. So g of x is our transform function. We obtain it by taking f of x and adding by c. So what I'm going to do is click on this button and it's going to change what c is equal to. Okay, so we'll just let it keep going for a second here. So let's let that be 1. So hopefully you can agree that C will create a vertical translation. Okay, whether it's upwards or downwards, well, it depends on what the value of C is. If C is 1, like I've made it to be, then we have a vertical translation 1 unit up. If C is equal to, I don't know, like -3, you translate it 3 units down. And it makes perfect sense because look at the equation, right? F of x is the original output. And what are you doing to the output values of your parent function? You're adding by C. So if you think about it, you're taking all the original y values and you're adding by C. So that means graphically, you're going to apply some shift depending on what C is. If C is some positive value, all the y values, all the previous y values will be increased by C, and then you see a shift upwards. So if it was like, I don't know, like 4, then you take all the previous coordinates, okay, take the y coordinates specifically, and then increase them by 4, right? That's what the equation is saying. You take the previous output values of f of x and add by c. And the previous output values are the previous y coordinates. Okay, so that's C. Let's talk about D. Oh, oops, let's go back for a second. I forgot to mention, I did promise you, it doesn't matter what the original function is. Okay, it could be the square root function. It could be the absolute value function. Okay, no matter what it is, we're talking about a transformation, a vertical translation, C units up or down. Okay. All right. What about D here? Let's move this here. So what I have here is the absolute value of x, and same idea, but now it's g of x is equal to f of x minus d. So f of x being our parent function. And what is the effect of d? F of x minus d. So let's click on this button and see what happens. Interesting. Okay. So hopefully this brings back memories from last year. When d is positive, you're shifting to the right. When d is negative, you're shifting to the left. So let's make d to be 2, for example. So you're going to see g of x equals f of x minus 2. Why is it that when it's f of x minus 2, we're shifting 2 units to the right? Well, it makes sense if you think about it, because f of x minus 2, let's look at the inputs, okay? What we have here is we're taking the previous inputs and subtracting them by 2, right? But if you want the same output values as before, if you want the same y values before, how do you offset the effect of subtracting by 2? If you're being subtracted by 2, that means you have to take your previous x values and increase them by 2. If you take your previous x values and increase them by 2, then you'll have the same output values. You'll have the same y values before. So that's why when it's x minus 2, it's a 2 unit shift to the right, because you have to increase the previous x values by 2. And if it was, I don't know, -3, it makes sense to be a 3-unit shift to the left, okay? Because in the equation, it'll be f of x plus 3. Well, wait a minute. F of x plus 3, if I want the same output values, then I have to take the previous x values and decrease them by 3. Okay, so really study the equation. Okay, that it will tell you what kind of transformation you have. What you're used to last year is x squared. Okay, remember when it's x plus 3 all squared, that means a 3-unit shift to the left. So that is the exact same reasoning as last year. Okay, so last year was h, but now it's d. So hopefully that doesn't bother you too much. It's the same idea. So if it was -1, that's a 1-unit shift to the left. You have to decrease the previous x values, and if you want to get the same y values as before. Okay, and then we have a combo here. You can change d and change c. Okay, and it doesn't matter what the function is. It could be the square root function. It could be the reciprocal function, quadratic function, linear function, so forth and so on. Okay, so now we know what d and c does.
Okay, so hopefully the animation was helpful. So now let's try to answer these questions. Describe how the value of c in g of x equals f of x plus c changes the graph of g of x. So it's a vertical, whatever c is, it's a vertical translation by c units. Okay, and if c is greater than 0, translate up or upwards. If c is less than 0, we translate downwards. Let's use better words. Upwards, downwards. All right. So one very important thing to understand is that no matter what you choose the base function or the parent function to be, it's going to be the same. C will still represent a vertical translation up or down. And the rationale or the reasoning, quite simply, is because C, the way C works is the same no matter what the parent function is. The way it impacts the points on your parent function will always be the same. So xy will no longer be xy, it'll be x will be the same, but it'll be y plus c. And when you take your y coordinates and add by whatever c is, you're going to get a vertical translation. And using this logic, you can pretty much explain the same thing with horizontal translation. So it's a horizontal translation by d units. If d is greater than 0, you translate right. If d is less than 0, you translate left. Okay, why is it that no matter what the parent function is, the effect is the same? Because it's the way d impacts the points on your parent function. Right? So we're always taking the original x values and adding by d, so that will create a shift, a horizontal shift, whether it's left or right. Okay? The summary page is perfect, or the summary box. You can read it over, but that's basically what I was trying to say from the 4 questions above and from the animation. Okay? I will say one thing that really confuses students is the horizontal. So now let's see, what do we have to do? I have to sketch the transform function. Given the parent function, state the domain and range of the transform function. All right, okay, so D here is -5, C here is -1. So that means I'm shifting 5 units to the left, 1 unit down. So I'm going to take my original points and take the x coordinates and subtract by 5. Take the y coordinates and subtract by 1. All right. Well, you know what? This is great. This is very nice. But what I have to do is transform the points, right? I need to know my original points. What am I transforming? Well, since it's the reciprocal function is the parent function, these are the points I'm going to work with. These are the points I'm manipulating. All right. So these are the points on f of x. These are the points on g of x. Do I really care about the points of f of x? No, I'm just using them to help me find g of x. So take all the previous x values and subtract them by 5, which makes perfect sense because I'm shifting 5 units to the left. I'm taking the previous y values and subtracting them by 1, which once again makes perfect sense because I'm shifting 1 unit down. Then, okay, so the first thing I'm going to do is I'm going to sketch in the asymptotes because that's going to give me a nice guideline of how my graph should look. So because I'm shifting 5 to the left and 1 down, I know that my horizontal asymptote will be at y equals -1 now, right? It used to be on the x-axis, but because I shift 1 unit down, it'll be y equals -1. And because I shift 5 units left, it will no longer be the y-axis, it'll be at x equals -5. I count right? 1, 2, 3, yep. I think my eyes are going bad. All right, so now that gives me a nice little guideline on how this graph is going to look. So let's plot this here. Beautiful, -3, -0.5. Nice, very pretty. And I see that symmetry, very nice, very nice. -7, -1.5. Okay. There we go. Okay. And it's really helpful to know the domain and range of the parent function because the domain and the range of the transform function will not be exactly the same, but it will resemble, it'll have the same format. Okay, so with the reciprocal function as x can't be 0 and y can't be 0, but for the transform one, it will be instead of x can't be 0, it'll be x can't be -5. And for the range, instead of saying y can't be 0, it'll be y can't be -1. Okay, looking good. Very pretty. Alright, so let's state what d and c is. d is 2, c is 4. What am I transforming? The square root function. Well, it doesn't really matter. I'm transforming square root function. How I'm changing or how I'm affecting the coordinates will be the same. I'm going 2 to the right and 4 up. Oh, whoops, I've made a mistake. I should indicate the scale on the x and y axis. There we go. All right, back in business here. So I'm going to get the key points for the original, which is a square root function. No problem. So it'll be 0, 0, 1, 1, 4, 2, 9, 3. Perfect squares, right? And that will enable me, well, that in conjunction with the mapping rule will enable me to get the key points for my transform function. So take all the previous x values and add by 2, so that. And then take the previous y values and add by 4, so we got something like that. Now I'm just thinking, am I going to plot 11, 7 or just plotting 3 points and I'm happy? Alright, I'll just plot them all. I'm going to change the scale up. Okay, I'm going to change the scaling so it's 2 and 2. So 2, 4, 3, 5, 6, 6, 2, 4, 6, 2, 4, 6, and 11, 7. So that's 6, 8, 10, 11, 11, 7. Okay. And that's, what is it? G of x. Beautiful. All right. I wish it looked a little prettier, but you know what? I think I can live with it. So the domain and range of the square root function is, well, x has to be greater than or equal to 0, and the range is also greater than or equal to 0. So using that, you can have something very similar. Once again, not the same, but something similar, right? X is greater than or equal to 2. And the y values will be greater than or equal to 4. So if you forget, just look at the graph, right? Just look at the graph. The endpoint will dictate what the domain and range will be of the The endpoint will dictate what the domain and range will be of the transform square root function. All right, so we introduced horizontal and vertical translations, and the next transformation will be reflections.